right, now we're going to talk about a new product that we are looking to add into Grainger. So Eric, please tell us a little bit about this magnet separator and applications for it and any features that it may have.
Yeah, this is what we refer to as a B-trap. This is a liquid line trap, and we use it for liquid magnetic separation. You can see that we've got the element kind of popped out of the main body housing here, and we utilize magnetic fingers as effectively a filter for various types of liquids and other types of slurries. We make these in 2, 3, 4-inch diameter ports at the end. This one in particular is a 3-inch with the 14W LMO sanitary fittings. We are also manufacture this with NPT threads on the end, so if somebody wants to thread it into place. And then through Grainger sourcing, somebody could certainly purchase it with, just butt ends if they wanted to weld the housing into place, or some of the other fancier, threads or different types of ends. We also produce it with flanges, so if somebody wants to put 150-pound flanges on it, they can bolt this into place as well. The housing itself is cast 316 stainless steel. This thing is, I don't like saying bomb proof, but it's pretty darn close to being, some type of explosion proof, just in terms of its overall durability. The elements are removable and of course replaceable. So if somebody, has a drop on the floor, if they see a temperature surge that's over the 250-degree Fahrenheit rating on these, we can easily replace the element itself as well. And then we provide it in a variety of different finishes. As far as this one here we're looking at is a food grade. This is a very sanitary unit, thus the 14W LMOs. And if you were to see the inside, it's basically a 32 RA polish on the interior, which, QA folks, sanitary people, that's spot on for them. It's pretty darn close to a USDA type standard. Somebody, again, maybe like a machine shop where they'd have the NPT fittings on the end, they're not looking for it to be that sanitary. The inside might just be a rough casting that's been bored out a little bit.
So a question about this, how often would a customer need to actually take the magnets out to clean them or remove what they've caught? How often do they check that?
That's the most difficult question to answer, but to actually get the answer, it's not too bad. So I'd like to tell people when they first purchase the unit, check it after an hour of running. And if nothing's on there, great. Check it after a half shift of running. And if nothing's on there, great. Check it after a full shift of running. Just keep going through that process till you figure out, like, when is the magnet?
Often?
Yeah, when is the magnet getting too convoluted that there is potential to block the pipeline because it's amassed so much ferrous and 400 series stainless from the process itself. It's more of it's a feeling process more than it is a measurable metric.
I guess something else you could do probably is downstream, you could add a pressure gauge maybe, and when you see what the stable normal operating pressure is, if you see it increasing, then that's a good example or good time to take this apart and see how much is in there, because you probably got a little bit of blockage, like you said.
Absolutely, and we do that. We make a larger version called a T-trap, and it's basically a fabricated version of this for sizes that are 6 inches all the way up to 24-inch diameter, 30-inch diameter pipes.
Wow.
And going back to our discussion on lumber industry, we use a lot in the paper pulp tissue industry to, because they're shredding up pallets. Pallets have nails in them. Nails don't go well in toilet paper.
Yeah, that would not be pleasant.
And it's not just from the rust or the discoloration. You don't want foreign debris in there. So we utilize a much larger version of this, and they do exactly what you mentioned, James. They put a pressure sensor downstream, and then they have one upstream as well, so they can see that delta. If it's starting to get backed up on the one, then they realize, I think the magnet is dirty. In an instance like that, or even a small magnet like this, if the process is very dirty, so to speak, where they have to clean this frequently, buy a second element, clean that element that you just pulled offline, put the new element back in.
That way you can keep your process going.
Exactly, because time's money, right?
Oh,
so the more time you're spent cleaning the magnet, which is just doing its job, and it's going to do it very, very well, the less time that you're actually producing. So having a spare magnetic element is a huge upside to productivity. You get this complete with the clamp and the O-ring that's in here. All the equipment that we supply, we sell spare parts for directly. I mentioned I was director of aftermarket previously. I'm a big proponent of buy those spares in advance.
Yes, because the downtime, it's just...
People call in a panic. They're freaking out. Some instances, they might have to send employees home because they've got to shut things down because critical control point at their facility is down and out for days,
That-
months.
That's what Granger's known for,
Yeah.
maintenance, repair, and operations. You know, their tagline for the ones who get it done. You know,
That's right.
they want to get it done. They want to make sure that their customers are operating. They don't want downtime.
Yeah.
So that's critical. What types of customers would be interested in this type of a product?
Yeah, I would say the biggest customer for this type of equipment is food producers. They have to do certain things to protect their customers and protect their brand name.
Yeah.
Right? And nobody wants to get a piece of metal in whatever their food, their consumable is, right?
Yeah.
So they go, and of course there's also the matter of equipment degradation too. That metal gets further downstream and now it starts to wreak havoc in the process and beats up other equipment, and we're back to that whole downtime situation. So food, pharmaceutical, chemical, plastics industry, polymers will utilize the traps because when they're manufacturing polymers, it lends itself to chemistry at that point. So it's almost like a chemical producer, just a different industry classification. But I would say those are probably four of our biggest consumers of a product like this.
And what type of a magnet is this? Because there's different types of magnets.
Yeah, absolutely. So this one here is going to be our strongest. This is what we call our extreme rare earth. We developed this a couple years ago, and it balances high pull force with Gauss. So for the nerds in the audience, this does a great job of balancing those two data points. This is a rare earth, and rare earth is really designed to remove fine iron. In fact, if you can see up close there, we actually have some fine iron on the little rings around the poles itself. So it's kind of grabbing, that's basically shop dust from us up shipping the unit. Ceramic magnets are really designed for nuts and bolt type applications. Largely, we see people having a ceramic magnet ahead of a rare earth magnet to come kind of clean up, right? So we get out as much as we possibly can with the ceramic magnet, and then we make sure nothing is in there down to, you know, some level of microns that the rare earth is able to separate out of the product.
Don't forget to scan the QR code down below for additional resources. We provide links to Granger.com and Eriez products, as well as their website, social media, and other great information. So scan that QR code down below.